Hello everyone, welcome to this exciting journey into the world of AI agents. In this beginner-friendly tutorial, we'll learn how to build our very own AI agents. Don't worry if you're new to this. We'll break down each step in a simple and easy-to-understand way. AI agents are like smart computer programs that can make decisions and take actions on their own. They are becoming increasingly popular because they can automate tasks, solve problems, and even entertain us. Whether you're interested in game development, automation, or just curious about AI, this tutorial is for you. Let's get started and bring your AI agent ideas to life. Imagine you have a little helper inside your computer that can do things for you. This helper is like an AI agent. It can perceive its environment, make decisions based on what it observes, and then take actions to achieve a specific goal. For example, imagine an AI agent that plays a game of chess. It can see the positions of the pieces on the board, decide its next move based on its strategy, and then move its pieces accordingly. AI agents are designed to be autonomous, which means they can operate without constant human intervention. They learn from their experiences and improve their performance over time. Just like we learn from our mistakes, AI agents can also learn and adapt. There are different types of AI agents, each with its own strengths and weaknesses. Understanding these types can help you choose the right one for your specific needs. Let's take a look at some common types and explore how they function in various scenarios. Simple reflex agents. These agents react directly to their environment based on predefined rules. They do not have any memory of past actions and make decisions solely based on the current situation. For example, a simple reflex agent controlling a thermostat might turn on the heater if the temperature drops below a certain threshold. This type of agent is straightforward but can be limited in complex environments. Model-based agents. These agents build a model of their environment and use it to make predictions and plan their actions. They have a better understanding of their surroundings compared to simple reflex agents. For example, a model-based agent navigating a maze would create a mental map of the maze to find the shortest path. This allows them to handle more complex tasks by considering future consequences of their actions. Goal-based agents. These agents have a specific goal in mind and take actions to achieve that goal. They evaluate different actions based on how well they move them towards their goal. For example, a goal-based agent playing a game would aim to win the game by making strategic moves. This type of agent is useful in scenarios where achieving a specific outcome is crucial. Learning agents. These agents can learn from their experiences and improve their performance over time. They adapt to new situations by updating their knowledge base. For example, a learning agent playing a video game would learn from its past mistakes and develop better strategies. This makes them highly versatile and capable of handling dynamic environments. The type of AI agent you choose to build will depend on the specific task or problem you want to solve. Each type has its own advantages and is suited for different applications, so understanding their differences is key to making an informed decision. To build AI agents, we need special tools and programming languages. Don't worry, you don't need to be a coding expert to get started. There are many beginner-friendly tools available. One popular programming language for AI is Python. It has a simple syntax and a large community of developers, making it easy to learn and find help when needed. Another great tool is Google Colab, a free cloud-based platform that lets you write and run Python code in your web browser. For building AI agents, we often use libraries or frameworks, which are collections of pre-written code that simplify the development process. Some popular libraries for AI include TensorFlow, PyTorch, and scikit-learn. These tools provide us with the building blocks for creating intelligent agents. Section 5. Step 1. Defining the agent's environment. The first step in building an AI agent is to define its environment. This is crucial because the environment dictates how the agent will perceive and interact with the world around it. The environment is the world in which the agent operates and interacts. It can be as simple as a game board or as complex as a bustling city. It includes everything the agent can perceive and interact with. This could be objects, other agents, or even natural elements like weather conditions. For example, if we're building an AI agent to play a game of tic-tac-toe, the environment would be the game board itself. This is a controlled and predictable environment. The agent needs to know the size of the board, which is a 3x3 grid in this case, the current state of the game, which squares are filled and by whom, and this information must be updated in real time. The rules of the game. These rules define what moves are allowed and how the game progresses. We can represent the environment using code. This involves creating data structures that accurately reflect the state of the environment. For the tic-tac-toe example, we could use a list of lists to represent the game board, where each sublist corresponds to a row on the board, where each element in the list represents a square on the board. This allows the agent to easily access and update the state of the game. By clearly defining the environment, we provide the agent with the necessary information to understand its surroundings. This foundational step is essential for the agent to make informed decisions and perform effectively. Section 6. Step 2. Designing the agent's actions. Once we've defined the agent's environment, we need to determine what actions the agent can take within that environment. Actions are the ways in which the agent can interact with and potentially change its environment. In the tic-tac-toe example, the agent's actions would be to place its mark, either an X or an O, in an empty square on the board. Each action would change the state of the game. We can represent the agent's actions using functions or methods in our code. Each function would correspond to a specific action the agent can take. For instance, we could have a function called that takes the row and column of the square as input and updates the game board accordingly. By defining the agent's actions, we empower it to make changes in its environment. Section 7. Step 3. Creating the agent's sensors. To make decisions and take actions, our AI agent needs to perceive its environment. This is where sensors come in. Sensors are like the agent's eyes and ears, providing it with information about the environment. In the tic-tac-toe example, the agent's sensor would be a function that observes the current state of the game board. It would tell the agent which squares are empty, which squares are occupied by X, and which squares are occupied by O. We can implement sensors using functions that return information about the environment. For example, we could have a function called that returns the current state of the tic-tac-toe board. Sensors enable the agent to gather the necessary information to make informed decisions. Section 8. Step 4. Implementing the agent's logic. Now comes the heart of building an AI agent, implementing its logic. This is where the agent starts to come alive, making decisions and taking actions based on the data it receives. The agent's logic determines how it makes decisions based on the information it receives from its sensors and the actions it can take. Essentially, it's the brain of the agent, processing inputs and generating outputs. There are many approaches to implementing agent logic, ranging from simple rule-based systems to complex machine learning algorithms. Each approach has its own strengths and weaknesses, and the choice depends on the specific requirements of the task at hand. For our tic-tac-toe agent, we could start with a simple rule-based system. This involves defining a set of rules that the agent follows to make its moves. For instance, we could define a set of rules such as, if there's a row or column or diagonal with two of the agent's marks, place the third mark to win. This is a straightforward strategy that can be very effective. If the opponent has two marks in a row, column, or diagonal, block them. This defensive move is crucial to prevent the opponent from winning. Otherwise, place a mark in a strategic position. This could be the center of the board or a corner, depending on the current state of the game. We can implement these rules using conditional statements and loops in our code. This involves writing if-else statements to check the conditions and execute the corresponding actions. The agent's logic is what makes it intelligent and allows it to make strategic decisions. By carefully designing and implementing this logic, we can create an agent that performs well in its environment and achieves its goals. Section 9. Your AI agent journey begins. Congratulations! You've learned the basic steps involved in building AI agents. Remember, this is just the beginning of your exciting journey into the world of artificial intelligence. Start by experimenting with simple AI agents like the tic-tac-toe agent we discussed. As you gain confidence, explore more complex environments, actions, and agent logic. There are endless possibilities. There are many resources available online to further your learning. Check out websites like TensorFlow's official website, PyTorch's documentation, and online courses on AI agent development. Embrace the challenge, have fun, and who knows what amazing AI agents you'll create.